Okay, in previous videos, we set up and ran a very simple thermal analysis in Climate Studio. We did several iterations, different runs, where we changed some variables and compared the outputs so we could understand the variety of outputs that we have access to in Climate Studio. What else can we do? Well, we have created a zone. We've added windows. We could add interior glazing if we wanted to. I'm not going to do that right now. I think I will add some shading. So let's talk about why we might do that. If we look at this is the last run we did where we added the glass. For example, if we look at the run before it, we have no cooling load here. We have heating load. Of course, this run was a building with no windows, something that we would never do probably. So it was just conceptual. But so here are the energy flows for that run, and then when we add the glass, we get a lot of gain. So the orange is glass or glazing, and we get a lot of gain, solar gain, through that glazing. And that's what's causing this cooling load now. The difference between this and this, the blue is the cooling load. So this is too simplistic a way of looking at it, but let's just learn about the workflow by trying to get rid of this or adjust this cooling load, the stuff in blue. So how would we do that? Well, first of all, we see that the load is in June, July, August, and September. So if we how much shade do we want? Where should we put it? Well, one way to start thinking about that, and a real power of Climate Studio, is we can switch quickly to our site analysis tool and turn the sun on. First thing we notice is that it's not that easy to tell where the shadows are. And why is that? That's because I had decided to make these layers opaque. So I'm going to come back here and make them solid. While I'm here, just to show you, maybe I don't like that weird purple. So I'll turn it. Well, I'm not saying it's weird, but I'll make it a different color. The point is that what's going on in the graphics window is not what we're modeling in the thermal analysis, so you just need to understand the difference, and that's part of what I'm showing you here. But even now, then, if I move the sun through the year, we really can't. We can start to see it on the east and west, but we can't see it on the south. And that's because these windows, remember, are just surfaces. They're coplanar to the surface of the wall. So this surface and this surface are coplanar. So a way we can quickly make this clearer is to model the same geometry but with the windows cut out. So let's now then look at the sun. One thing we should remember, and so always when you're modeling any kind of variables, you need to have a basic understanding of the a conceptual understanding of what you're modeling. So we need to understand the sun, and we already know that on the north side in New York City, in the northern hemisphere where we are, we're probably not going to get very much, if any, direct sun through the north because of the way that the solar window works. Even in the summer, when we're rising and setting pretty far to the east and west, it's not far enough probably to get any direct gains. Let's see if that's true. If I let's say I'll start at 12 o'clock and I'll just move through the entire year. I'm looking at the north side here. We're not getting any sun through that glazing. Through that face. And so that's what we would think would be happening. All the sun you're seeing there is coming from other faces. And we could, so we're probably not even going to try any overhangs on the north side, though we could. We could quickly simulate them. Maybe we'll do that. But let's now look at, and so the point I'm making here is that we can use the graphic interface tools in Climate Studio to think about what we're designing before running actual simulations. And so we go back and forth between these different workflows. If I So what we're saying is that the cooling load is June through about sometime in September, right? So let's just look at that. Let's isolate that time period. We'll start on the east side, and so the sun's rising on the east. So let's say that we want to really start looking at 9 o'clock in the morning. At the beginning of the summer, or the cooling load time, we have a fair amount of sun on the east side, and that continues through the entire summer at 9 in the morning. If we go later, we get less, but we still have plenty. So we would probably want to try an overhang of some kind. So let's try that. This is a 6-foot overhang. We can try whatever we want, but let's just start with that. And I'll go back to the beginning of the cooling period and move through it. So this is our cooling load period in the model right now. At 9 in the morning, we're not getting any direct sun. And then actually, as we go later in the morning, we get even less. So this overhang definitely will shade the east side when we want it shaded. Let's move around to the south. The south, let's look at noon, because that's when the sun's going to be directly, we can remember that by looking here at our solar window chart. In the summer at noon, we are getting a fair amount of sun coming in on the south side. If we move to 1, it's the same thing. So we are getting some sun in there. So let's try an overhang here also, using the same size, 6 feet. If we look back through the whole summer, we definitely have blocked all the sun. However, if we go back and look, let's say in February when it's really cold, we are getting some sun in, but we would get much more if we didn't have this overhang, right? And so let's say we had a passive solar design concept, but we were collecting sun on a thermal mass in this floor. We may not want that large of an overhang or any overhang at all. And so we would tune this based on that balance. So how about if we just switch this to a 2-foot overhang? Again, we're not trying to do design here. We're just learning the workflow, but we got to start somewhere. I mean, we got to have some kind of inputs. Okay, so now let's look at the west side. It's the sun is hot in the afternoon on the west in our hemisphere. If I go to my cooling load period starting in June and move through it, we see that with this 6-foot, well, actually, let's do it without it. There's a lot of sun getting in there, and that's only at 2 o'clock. If we go to like 4 o'clock, or there's a huge amount. So we definitely want to look at overhangs. So I'll try the same size. At 2 o'clock, 1 o'clock we're good, 2 o'clock we're good in June. But even at 4 o'clock, even at this time of year, and it's going to get worse as we go a little bit later into the summer, we have a fair amount in there. So we could make this larger, but it's definitely helping in terms of the amount of sun we're that's accessing the western side. So let's just say the point is here that I quickly went and did some visual analysis and picked some strategies for shading that I want to try. So now let's add that shading to the model. So if I go back to my thermal analysis tool, this is important because if you don't, and I think I'll just go back to the shaded view. If we don't actually add these shading devices to the model, even if they're on in the graphics window, they will not have an effect. And this this is a simple model, we would figure that out. But if you're running a more complicated model, you really need to keep track of all this. And so this is something I say over and over again. If we were engineers, 50% of being an engineer is being organized. Architects can be a little bit more loosey-goosey sometimes, but really when we're doing this kind of stuff, we need to be focused and organized and make sure we understand what's on, what's off, what we're keep track of exactly what the variables are. or we will do more harm than good. Oh, and, okay, so I'm going to select, I'm going to turn on, I'm just going to do the east and west first. I'm going to turn on that layer or select those objects and add them as shading objects, and then you see they show up down here, and they're on in the model. So, but now let's get rid of, this is not what we're modeling, remember. We are modeling, here's our actual thermal model. That was just so we could look at the sun. Let's then run this simulation. And again, remember there's this DOS window. Oops, that's the wrong thing. I have two screens, and so the actual model is running on my other screen. So I've run all these models, so that's why there's more named runs here. This is the last one we did in the last video. So without shading, we're at 74 side EDUI with this cooling load down here. And if I add the shading, I get a little bit better site EUI, but I definitely get a lot better cooling load situation. So between here and here, big improvement. However, if you watch the heating load, we're actually we have a lower heating load in our previous model. So by shading these windows in the summer, we're also shading them somewhat in times that we were gaining heat during the winter, and so we don't get as much of a benefit as we would as we do get a reduction in cooling load. All right, so let's try to add the north shade, and actually I think I'm going to let's start with it larger. No, actually let's not. Let's just run it the way we kind of deduced. So I'm going to add this shading to the model. Oh, sorry, I have to select it. So now it's showing up here. I run this simulation. Here's the model running. So you should see that window when you run these. Now we're actually back to the original. So without any shading, this was our run, and with the shading that we on both sides, this is our run. So we actually have done a lot to reduce the cooling load from here to here. But now when we added this southern shading, we really lost. We gained heating load because we were blocking the sun at a time when we might want it coming in. Oh, and let's do one other thing. Well, let me make this comment, and then as the last thing, we'll throw up some shading on the north and see if it has any effect. The two things that we're learning here in this short video. One, just how to set up shading elements, and because by the way, if I now came and changed this this shade and made it longer, since I've already got it as an element, and if I were to rerun this, I don't have to change the actual shading device because it will update. And so you see we have actually a much higher EUI now because we have a higher heating load because we're blocking a lot of the sun when we were gaining it in the winter before, and therefore having to produce that heat with some kind of mechanical system. Okay, so two things that we're learning then: how to set up shading, and also maybe if you've done some shading in designs before where you're using your common sense, you might realize, just even in this short little example, that it's not that simple, and that we really, to do adequate shading design, we need to do a model like this where we can actually compare the heating and cooling loads. And then when we get into daylighting, it's going to be a whole different approach to the same physical concept of shading. So these models really help us to collate all of our architectural design ideas into something that's going to work from a performance standpoint. Okay, as a final thing, let's just test I'm going to get rid of all this. You have to remove the shading. If you turn it off in the model, it doesn't matter. Let's just see if I add, so my theory was that I'm not going to change, so our original shading with, let's see, with just the glazing and no shading, this is the run. So my theory is that if I am shading on the north side, that this should not change at all. So let's see, I'm going to add this as a shading element, run my model. And you see we get the exact same output. So what we know in terms of our analog looking at the sun in site analysis in that situation bore out correctly in our more detailed simulation. So that's the other thing, is you want to always be checking these simulations, seeing if they make sense to you. If they don't, go figure out why and either fix something or learn something.